Okay, so in this video what we're going to do is we're going to look at some formulas for how to take the derivative of the natural log of x and also apply the chain rule to taking the derivative of the natural log of some other function of x that is more complicated than just x. So this is a first rule that we should remember, and this is true for when x is greater than 0. So x is in the domain of the natural log, then the derivative of the natural log of x is just equal to 1 over x. So there's a bunch of different ways that we can apply this rule and add this rule to all of the other rules that we have for taking derivatives. So maybe the simplest way would be to say, let's say we have something like y is equal to 5 times the natural log of x. And again, we're just going to assume that x is greater than 0. Or the argument of the function is within the domain of the natural log. But for the first few times, I'll just write it out. So y is equal to 5 times the natural log of x for x is greater than 0. And what we want to do is we want to find dy dx. All right, then what I would do is I would say dy dx is equal to d dx of 5 times the natural log of x. And then I can use this thing called the constant multiplier rule and pull out the 5 in front, and that's d dx of the natural log of x. And again, now we have this rule that tells us that d dx of the natural log of x is equal to 1 over x. So this here is 5 times 1 over x, which is 5 over x. Okay. So that's probably the most simple way to extend this rule to something a little bit more complicated. We could say also combine this with the sum difference rule and say something like y is equal to 3 times the natural log of x plus x to the 4th. All right, and again, this is going to be for x is greater than 0, and we want to find dy dx. Then in this case, again, we start by saying dy dx is d dx of 3 times the natural log of x plus x to the 4th. And then we can apply this sum difference rule and the constant multiplier rule to say that this is 3 times d dx of the natural log of x plus d dx of x to the 4th. All right, and this is equal to, again, 3 times 1 over x, which is d dx of the natural log of x, plus d dx of x to the 4th, and that's going to be 4x cubed. So we could write this as 3 over x plus 4x cubed. Okay, so then we also have some other rules that we've talked about, and those rules are the product rule, quotient rule, and the chain rule. So let's say that we were going to look at an example of including this rule in the product rule. Let's say that we have, for example, y is equal to x to the 5th times the natural log of x. All right, and again, this is for x is greater than 0, but I'm not going to write it down every time. And we want to find dy dx. So I can say dy dx is equal to d dx of x to the 5th times the natural log of x. All right, and then we have this product rule that says fg prime is equal to f times g prime plus g times f prime. All right, so that's the first function times the derivative of the second plus the second function times the derivative of the first. In this case, we'll say x to the 5th is f, and the natural log of x is g. All right, so if I work this out using the product rule, this says that dy dx is equal to the first function, x to the 5th, times d dx of the natural log of x, plus the natural log of x times d dx of x to the 5th. All right, so then if we use our rule for logarithms, this is x to the 5th times 1 over x. All right, and then over here, this is going to be plus the natural log of x times 5x to the 4th. All right, so we can simplify this. X to the 5th times 1 over x, that's x to the 5th divided by x, so that's x to the 4th. And that's going to end up being plus 5x to the 4th times the natural log of x. All right, so again, we're just taking this basic rule, d dx of the natural log of x for x is greater than 0 is equal to 1 over x, and just including it with all of the other rules that we've already learned, you've already learned in the course of this class. All right, and we could say, look at one other case here, and we could say that, for example, y is equal to the natural log of x over x to the fourth, and we want to find dy dx, and this is again for x is greater than 0. All right, so we have the quotient rule, which is f over g prime equals g f prime minus f g prime all over g squared. And so again, we're going to do the bottom times the derivative of the top minus the top times the derivative of the bottom, and that's over the bottom squared. So this is going to end up being dy dx is equal to x to the fourth times d dx of the natural log of x minus the top function, which is a natural log of x, times d dx, or the derivative of the bottom. And all of that is going to be over the bottom function squared, which is x to the fourth squared. All right. So if I work this out a little bit more and I calculate these derivatives, that's x to the fourth times 1 over x, and that's minus the natural log of x times 4x cubed, and that's all over x to the eighth. All right, and so x to the fourth times 1 over x is x cubed, minus 4x cubed times the natural log of x, and that's all over x to the eighth. Okay, so again, if we take x, this term here, some people have trouble with x to the fourth, the quantity squared. We're raising a exponential to an exponent, so we multiply the exponents, which is where we get this x to the eighth. Okay, you might see it on your MyMathLab simplified a little bit further. And in that case, what you might do is factor out an x cubed from the top, and that's times 1 minus 4 times the natural log of x, and that's all over x to the eighth. And if I have 3 of these x's multiplying themselves in the numerator and I have 8 of them in the denominator, then that basically means that this x cubed cancels 3 of the x's down here and gives me an x to the fifth. And so this is going to be 1 minus 4 times the natural log of x divided by x to the fifth. Okay, so these are a bunch of different ways to apply this fundamental rule that d dx of natural log of x is equal to 1 over x for x is greater than 0. What we're going to look at in the next video is how to combine that rule with the chain rule and figure out a way to find the derivatives of function when the argument of the function is a bit more complicated than just x alone.